Ever wondered if a complex system could influence its components rather than the other way around? Imagine you're driving on a busy highway. The flow of traffic, a collective behavior, often determines your speed rather than you determining the traffic flow. This is a simple example of what scientists call top-down causation, a concept where the whole system governs its parts. It's a bit of a head-scratcher, isn't it? We're so used to thinking in terms of bottom-up causation, where the smaller components, like individual cars, dictate the behavior of the larger system, like the traffic flow. But top-down causation flips that idea on its head. It suggests that sometimes the large-scale system can impact the behavior of its smaller components. It's like a shift in perspective, a new way to view the world and the complex systems within it. Intriguing, isn't it? The idea that the whole can govern the parts. Now let us dive deeper into the world of top-down causation. Imagine a world where the whole influences its parts, not the other way around. This is the world of top-down causation, where the system as a whole exerts control on its individual components. It's like the human body. Our brain, the control center, sends out signals which govern the actions of our limbs, our organs, our cells. It's not the individual body parts calling the shots, it's the brain, the whole, in control. This idea challenges the traditional view of causation, which is often seen as a bottom-up process. In a bottom-up world, the smallest components come together to create the whole. Think of building blocks forming a tower, or individual notes composing a symphony. But top-down causation flips this concept. It's the tower deciding the placement of the blocks, the symphony dictating the notes. Interestingly, this concept isn't just philosophical musing, it finds resonance in the world of quantum physics. Godel's incompleteness theorem, a landmark in mathematical logic, has been extended into the quantum realm. It suggests that a complete microscopic description of a material doesn't necessarily predict its macroscopic behavior. This challenges the reductionist viewpoint, which tries to understand the world by breaking it down into smaller and smaller pieces. Top-down causation posits that understanding the whole is crucial to understanding the parts. Moreover, top-down causation also finds traction in natural laws. Physicist Paul Davies proposes that while physical processes depend on laws, the laws themselves do not depend on physical processes. This implies that natural laws can't be explained solely by bottom-up physical processes. They hint at a top-down causality. Finally, even the fossil record, a cornerstone of evolutionary biology, lends support to top-down causation. It shows that animal groups tend to reach their maximum diversity of form relatively early in their existence, a pattern called early high disparity. This challenges the conventional V-shaped cone model of evolution, reinforcing the role of top-down causation in shaping life. And just like that, we've turned the conventional understanding of causation on its head. You may ask, does this apply to the laws of nature too? Indeed, the concept of top-down causation extends to the very laws that govern our universe. These laws, whether they're the rules that dictate the dance of celestial bodies or the principles that guide the interactions of subatomic particles, are not influenced by the physical processes they oversee. Consider the law of gravity, a force that keeps our feet firmly on the ground and the planets in their orbits. We don't see objects influencing gravity, do we? Instead, it's gravity that determines how objects move and interact. The apple doesn't tell gravity how to work, it falls because of the law of gravity. This is a classic example of top-down causation, where the overarching law influences the behavior of the components within its realm. Likewise, think about the second law of thermodynamics, the principle that entropy or disorder in a closed system tends to increase over time. It's not the individual molecules that dictate this law, but the law itself that guides the behavior of the molecules, leading to the eventual increase in entropy. Now let's turn to quantum physics. Even within this realm, where particles can be in multiple places at once, and the act of observation can change the outcome, it's not the particles that define the laws. Instead, it's the laws themselves that govern how these particles behave. Even when we have a complete and perfect understanding of a particle's properties, we cannot predict its behavior without the laws that govern it. These examples demonstrate that the laws of nature are not the result of bottom-up causation, where smaller components give rise to larger systems or phenomena. Rather, they are the epitome of top-down causation, where the higher-level rules guide and influence the behavior of the lower-level entities. Paul Davies, a renowned physicist, put it best: "Physical processes depend on laws, but the laws do not depend on physical processes." This statement, widely accepted in the scientific community, is a testament to top-down causation in the laws of nature. So it seems that the laws of nature too dance to the tunes of top-down causation. What about evolution? Could it be influenced by top-down causation? A thought-provoking question indeed. Let's delve into some groundbreaking research that has sparked much debate. In an intriguing study, evolutionary biologists examined nearly 100 fossil groups to challenge the long-standing notion of evolution's gradual bottom-up progression. Their findings, a pattern they dubbed early high disparity. This pattern defies the traditional V-shaped cone model of evolution. Instead of taking millions of years for animal groups to reach their maximum diversity, the study suggests that this high disparity occurs early on, irrespective of when the group originated over the past 500 million years. This discovery isn't just tied to the first radiation of animals during the Cambrian explosion. What does this mean? It's possible that this early high disparity is a manifestation of top-down causation in evolution. From this perspective, the problem of biological form might be seen in a whole new light. So it seems that top-down causation might hold the key to some of the most profound questions in evolution. Top-down causation, a paradigm shift in understanding the world around us. We've journeyed together through the intriguing landscape of top-down causation, exploring its profound implications on our comprehension of the universe. We've revisited the fundamental concept, illuminating how it challenges the traditionally accepted bottom-up perspective. Our voyage took us through the realm of nature's laws, where we discovered that physical processes, no matter how complex, depend on laws that remain unaffected by these processes. This fascinating asymmetry is yet another testament to the power of top-down causation. We then ventured into the evolutionary domain, where the fossil record and the early high disparity pattern hinted at the potential role of top-down causation in shaping biological form. This intriguing perspective turns the conventional V-shaped cone model of evolution upside down, further challenging our understanding of life's complexity. Remember, in a world of top-down causation, it's the whole that governs the parts.